What's up, everybody? It's Dan from SageMathTutoring.com, and I am going to do a short video that has to do with how to make the unit circle from scratch, because that's a very important skill to learn in trig. All right, so bottom line is, first of all, it's going to be an XY coordinate plane, so you might as well just draw it. There it is. You also know that you're going to be dealing with a circle, so you might as well just draw that. Now, here's the way that I like to go about this stuff right out the gate. I like to recognize, first and foremost, that the angle measures are 0 and 2 pi. We're going to stick with radians for now. Now, if that's 0 or 2 pi, then half the distance would be pi. So I just remember that, pi. I do that right away. And then I ask myself, okay, well, if that's pi, then half the distance here is pi over 2. So I just write that. And then I play the counting game. I call it the counting game. 1 pi over 2, 2 pi over 2, 3 pi over 2. So I write 3 pi over 2. Now the truth is that I said 1 pi over 2, 2 pi over 2, which just turns into pi because the 2's cancel, and then we have 3 pi over 2. And then this, of course, would be 4 pi over 2 if I kept going, and that would reduce to 2 pi. But the bottom line is I paid attention to the fact that this is 0 or 2 pi, this is half of 2 pi, this is half of pi, and then I played the counting game around to remember that that's 3 pi over 2. At that point, what I like to do personally is start doing pizza pie slices. Now I'm going to make these very light. I start with the X's because they're kind of easy to draw, because it's easy to see where they belong. And then what I do is I go ahead and draw the other things. Actually, let's not. We're gonna stick with these. So then I ask myself, well, what's the angle measure here? Well, it's going to be half of pi over 2. What is that? That is clearly pi over 4. Half of pi over 2 is pi over 4. Then I play the counting game. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Notice how I always hit the north, west, south, east points. Every time I play the counting game, I always hit, I'm going to call them the cardinal points, the north, west, east, south points. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, right? 7 pi over 4, 8 pi over 4, also known as 2 pi. So now we just properly labeled those radian measures. Now at that point, I'm going to go ahead, and this one is a little tricky. You have to be careful. You got to be very precise. You got to cut through like that. All right, that's one. We're going to cut through in a similar fashion like that. And we're going to cut through very meticulously like that. And we're going to cut through very meticulously like that. Now for my students at home, just know that when you draw this, it doesn't have to take this long, because I'm explaining it while I draw it, which makes it take longer. Okay, actually I don't want to do that. So when you do this, it's going to be a lot faster, especially if you practice. So then you have to remember that this first one is pi over 6. You have to remember that. So unfortunately that is a memorization issue. But once you can remember that that's pi over 6, then you're going to only pay attention to the green ones and the cardinal points. And you play the counting game. 1 pi over 6, 2 pi over 6, 2 pi over 6, which we're going to worry about later. 3 pi over 6, 4 pi over 6, 4 pi over 6, which we're going to reduce later. 5 pi over 6, 5 pi over 6. 6 pi over 6, which is already pi. 7 pi over 6, which we're going to not reduce later. 8 pi over 6, we are going to reduce that one later. Let's make this pencil smaller. 8 pi over 6, it's right there. We have 9 pi over 6. Once again, remember, we're always hitting the cardinal points. That will reduce to 3 pi over 2, so that's 9 pi over 6. This is 10 pi over 6. Counting game never fails. That's a 6. 11 pi over 6. And then I ask myself, okay, great. I just did the counting game all the way around. But then some of the stuff can reduce. For example, 2 pi over 3, well, that's really pi over 3, right? 4 pi over 6 is really 2 pi over 3. We have what else do we have? We have that, 2 pi over 3. 3 pi over 4, 5 pi over, we have 7 pi over 6, we have 8 pi over 6, that's 4 pi over 3. 4 pi over 3. We have 10 pi over 6, which is 5 pi over 3. So I'm going to get rid of all the old ones, the outdated ones right now. I'm going to erase that one. I'm going to erase that one. And erase that one. And erase that one. Okay, so we just properly labeled the radian measures. Now, we could also talk about degree measures, but we're not going to do that just yet. What we are going to do is we're going to look very closely and we're going to ask ourselves, what about the points? Because there are points here, right? There are points, and we want to know what are the x and y coordinates of those points. Well, first of all, we know that the x and y coordinate is going to be encapsulated with parentheses. So I'm going to go ahead and just draw parentheses with a comma because I know I'm going to do that anyway. Why not do it now? I'm going to do it anyway. I like to do things systematically because I can go very fast, treat it like a system. The more you can be like a machine, the more you can set things up so you don't have to think too much. That will keep you in the flow. Another thing you can do is realize that all of these are going to be positive, but the x coordinates over here are going to be negative. So I'm going to put a little negative. Why not? Both the x and y's are going to be negative in this quadrant, so I'm going to go ahead and write that. This is kind of a special case. That's going to be 0, negative 1, so I'll put the negative here. So it looks like only the y's are going to be negative there, so I'm going to put a little negative there. Now, I focus on the cardinal points. These are easy to know. If it's the unit circle, that's going to be 1, 0, so you just write that. This is easy to know. This is going to be, actually I should have just called this 0. It's not negative. 0, 1. This one is easy to know. That's negative 1, 0. This one's easy to know. This is going to be 0, negative 1. So that's easy to know. Now I'm going to make these a little, actually we'll make them in purple. I want to draw attention to these. Draw attention to the cardinal points because these are going to be important for the next part. All right, so there's a systematic approach to doing this. Now, what you need to know, you could focus on quadrant 1. It goes from 1, an x coordinate of 1, all the way to an x coordinate of 0. As you go up, the x coordinates decrease. So that means you're going to go 3, 2, 1. And you put everything over 2. And you can say everything gets the radical. Now, radical 1 is just 1, so I'm not going to put a radical there, but you could. You could think of everything getting a radical. So it went from 1 rather, to 0, so the x coordinates decrease 3, 2, 1. The y coordinate goes from 0 to 1 as it goes up, so it's increasing, so that's going to be 1, 2, 3. That's increasing, so everything gets a 2, and then everything gets a radical, but we take into account the fact that radical 1 is just 1. Okay, so at that point, you can then treat these like they are mirrors, okay? For example, this point is mirrored right here, okay? So that's going to be a 1/2 there and a radical 3 over 2. Notice how, because I already took into account the signs, I don't really need to worry about that. Now, my handwriting is terrible, but I'm doing this quickly. When you do it, you should make your handwriting nicer than mine. Clearly, this one is going to be reflected with that one, so that's radical 2 over 2. Radical 2 over 2, and so on. So you would basically reflect this one across here. That would be 1/2 and radical 3 over 2. And at this point, you've got you could take your pick. I would treat this like a mirror and just reflect these over here. So this is going to be 1/2 radical 3 over 2, and so on. So what I'm going to do is basically keep going like this. Once I flesh this out, just know that you could treat this like a mirror and these reflect across accordingly. So I'm going to actually flesh this out right now. So now you might be wondering, okay, great, well, I got all the radian measures and so on, but what about the degree measures? Well, unfortunately with that, I would strongly suggest memorizing the fact that pi over 6 is really just 30 degrees. So I'm going to write that in purple, 30 degrees. I would strongly suggest memorizing the fact that pi over 4 is actually 45 degrees. And then I would strongly suggest recognizing that pi over 3, this is pi over 3, I should make that a little bit more clear. That's pi over 3. That is 60 degrees. I would strongly suggest recognizing that that's 90 degrees. I would strongly suggest recognizing that that's 180. Maybe memorize the fact that this is 270. So basically, it can't hurt to memorize all the degree measures in the first quadrant and all the cardinal points. In my opinion, you probably should memorize those because these are very famous angles, actually, that you should know. Other than that, you're going to reflect across. I think my student's teacher, I have a student who inspired me to do this. My student's teacher probably wants him to do this kind of reflecting thing where it's like, oh, okay, once you know that this is 60, well, this is going to be at least, what do we call it? Not coterminal, a reference angle of 60 right here. So it'd be 180 minus 60, whatever the hell that is. And that, I think, is 120, right? So that's going to be 120. You know, this one, the reference angle is 45, so it's going to be 180 minus 45, whatever that is. I think that's 135. 135 is right there. So anyway, you just have to kind of reason it out. The reference angle for 30 degrees would be 150. And yeah, basically, you just kind of use addition and subtraction. This is going to be 180 plus 30, so that's going to be 210. So there's really no fun trick. Like, you can't play the counting game with this crap. But at least you can kind of relatively easily reason it out. So this is going to be 180 plus 45. I think that's 225. Is that right? 225. This is going to be 180 plus friggin' 60. 240, I think. And then over here, I would say this is 30 degrees less than 360. So that's clearly 330. This angle right here would be 45 degrees less than 360. All right, so that's going to be 315. I'm going to use an arrow. Once again, make sure your handwriting is better than mine. My handwriting is terrible, but I'm trying to move fast because I actually have a tight schedule right now. So this is going to be 360 minus 60 to get to that one. That's clearly going to be 300. So I'm going to use an arrow for that as well. That's clearly going to be 300. Anyway, again, once you learn how to do exactly what I just did, you will be shocked with how quickly you can fill out an entire unit circle. I know that seemed like it took long, and I know maybe it seems like you don't have time to do that when you're taking a quiz or test, but actually you do have time to do it. You can do it very quickly. As long as you practice it, you can do it right away. And the reason why it's important is because once you have it in front of you, I mean, there's a whole subspecies of trig problems that become suddenly ridiculously easy as long as you're staring at the unit circle the whole time. So hopefully that makes sense, and I'll talk to you later. Bye.